My name is Laura Gomez-Rey, and this is my Physics 2212 lab on tape. Alright, so the main goal of this lab was to see the interactions between two pieces of clear tape that have been charged, and we got help from GlowScript to calculate the actual results, and predicting the tape charge, I predicted that they were going to repel from each other. And the results did end up showing that the tapes repelled when near each other due to the positive charges. They both had positive charges since they were both charged once peeling the tape. And then due to this, they obviously repel because they're the same charge. The electric charge on one tape was going to be 1.2 times 10 to the power of negative 8 coulomb, and the tape is deficient with 7 times 10 to the power of 10 electrons. So the main concepts we need to know to do this actual lab is Coulomb's law, which is force is equal to K times Q1, Q2 divided by R squared, and Newton's second law, which is F is equal to ma. So this is the observed model on the left here. You can see the second picture, that's before the second tape is added, and then the picture on the most left is the picture of once the tape was added, and you can see how the tape actually did lift up a little bit because it wanted to repel. So the original tape mass, or the tape mass, was 0.00248 kilograms, the tape length was 0.2 meters, and the tape width was 0.02 meters. And the distance between the two tapes ended up being 0.012 meters, and the tape was attracted to, besides this, after this was done and we had done the tape was also attracted to my hand. Was attracted to my hand because I'm guessing my hand had negative charge to it, and it was repelled by the piece of tape since it had positive. So this is the GlowScript code that I used. On the left, it helped me find the electrical charge of the tape from my previous observations, and the GlowScript code ended up showing that the charge of my tape was 1.2 times 10 to the power of negative 8 coulombs. Again, I got the help of using Coulomb's law formula, like a certain version of it, where we use the distance of the tapes and the actual charge. And then here you can see the distance between the two charges. And this is also another code that I ended up using. It shows that the tapes are seen as line charges instead of point charges because it just makes things a little bit easier. And then I examined the force on each charge in the top tape to see what the charge particles would end up showing. So our final results were that the magnitude of the electric force was 1.69 times 10 to the power of negative 5, and the code also showed that the magnitude of the gravitational force was going to be 1.96 times 10 to the power of negative 4. With these numbers, I was able to do some calculations and showed that we lost 7.5 times 10 to the power of 10 electrons, and the total area of the tape was 0.004, I believe, meters. And then the atoms on the tape was 10 times 10 to the power of negative 17. And with these numbers, we can actually create a ratio, which would be 1 electron per 1.88 times 10 to the power of negative 7 atoms. So those were our results, and some errors that could have happened while doing this lab is that a loss of charge could have happened when handling the tape, because sometimes tape was really sticky and really hard to work with, and I had to touch it more than I would have liked to, which would have exchanged some electrons from me to the tape. So in return, a loss of charge. And additional forces were not taken into consideration, like gravity or anything else that might have affected the charge that I wasn't aware of. And then the charges on the tape might have not been equal. There's no way of telling for sure since we used a computer-aided help from GlowScript. And for the what if questions, so what if the sign of the protons and the electrons were switched? if the proton and electron signs were switched, the observation still wouldn't change, other than we would now be losing protons instead of electrons, and the tape would still repel each other since the signs would still be different, and everything else would stay the same. It's the same thing, just kind of switch. Um, and why are the computational values for Q different? Well, one model is a line charge and not a point charge like the other one, and a line charge is definitely more accurate since it takes the tape length into consideration, unlike the point charge. And that's it. Thank you.